Good morning students. Today we are going to study about inverse system and deconvolution. So the topic of today's discussion is inverse system and deconvolution. So first we have to know what is an inverse system. A system is said to be an inverse one when the input to the system can be recovered from its respective output. This is possible only when the original system is cascaded with its inverse system, such that the output is equal to the input of the original system. To illustrate this, we can use this following block diagram. Let us say the input to a system is Xn. This is the system H of n. Output is Yn. So we are having this output feeding into an inverse system with impulse response H inverse n. Output of this will be equal to, let us say, omega n, which must be equal to the original input Xn. So mathematically, if we can write Yn is equal to A into Xn, then omega n must be equal to 1 by A into Yn, such that the output at this terminal becomes same as that of the input terminal. So from this block diagram, we can write in terms of convolution, output Yn is equal to Xn convoluted with H of n, and this omega n, we can write it as Yn convoluted with H inverse n. So substituting Yn over here, we can write it as X of n convoluted with H of n convoluted with H inverse n. So this can be further rewritten as X of n convoluted with H of n convoluted with H inverse n, which will finally give us Xn. So thus we can see that omega n, which is the final output of the block diagram, is equal to the original input Xn. So why we can write it? Because the product of these two functions Hn and H inverse n is equal to delta n. The convolution rather, this is equal to delta n. Next, we move on to the concept of deconvolution. Now, there may be a few applications where it is known to us the impulse response and the output of the system only, and we have to determine what is the input to the system. So, the process of recovering the input from the convolution of Xn and Hn is known as deconvolution. Now, how is it done? We know that the output sequence Yn is equal to k from minus infinity to infinity x of k input multiplied with h of n minus k. Assuming that y of n and h of n are one-sided finite sequences, we can write this equation as yn equal to, now the limits will change, it will be from k equal to 0 to n x of k h of n minus k. So from here we can see that y of 0, if I want to write, this will be h of 0 into x of 0. If I want to write what is y of 1, this will be h of 1 multiplied with x of 0 plus h of 0 into x of 1 and so on. So in matrix form, if I want to write, you can write it as y of 0, y of 1 and so on. This will be equal to another matrix. First is h of 0, then we are having h of 1, h of 0. These elements will be 0 multiplied with another matrix where we are having x of 0, x of 1 and so on. So the first matrix we can write it as capital Y. This we can write it as capital H, and this can be written as capital X. So we can write it as matrix Y equal to the product of H and X, which implies that if we want to find what is the input matrix, then X will be H inverse multiplied with Y. So if we go back to the first equations, let this be equation 1 and let this be equation 2. So from equation 1, we can write it y of 0 equal to h of 0 into x of 0. So to find the input x of 0, it will be y of 0 divided by h of 0. Similarly, from equation 2, y of 1 is equal to h of 1 x of 0 plus h of 0 into x of 1. So if we have to find out the input x of 1, this will be y of 1 minus h of 1 x of 0 divided by h of 0 and so on and so forth. So if we want to now generalize this equation, we can write any input sequence x of n, this will be equal to y of n minus summation of, this is x of k multiplied with h of n minus k. Range of k will be from 0 to n minus 1. Whole thing has to be divided by h of 0. So with this now we will solve a problem. Let us say you are given a problem where you have to find out what is the input signal xn. We have to find out what is the input signal xn that will generate the output sequence y of n 1, 5, 10, 11, 8, 4, 1 for a system whose impulse response Hn is equal to 1, 2, 1. So the number of samples which are present in the output is n1 plus n2 minus 1, and the number of samples which are present in the impulse response is only n2. So we are having here 3 and here we are having 7. So n1 will be equal to 5. How we are finding it? Again I am telling you. For the impulse response Hn, the number of samples, let us say n2, this is equal to 3. And for this output sequence, we are having here a total of 7 samples. So the formula over here will be n1 plus n2 minus 1 equal to 7. So from here, your n1 will be equal to 7 plus 1, that is 8, minus 3 equal to 5. So the total number of samples in the input will be equal to 5. So this is the first thing that you have to determine. Now you have to go by using the formula where xn is equal to yn, which is this one I am writing it as xn has 5 samples. So this will be yn minus, this will be limits from k equal to 0 to n minus 1, x of k, h, n minus k. Whole thing has to be divided by h of 0. So this xn, we have to write it a little down here. Okay. So for n equal to 0, x of 0 will be y0 by h0 equal to 1. For n equal to 1, we have to find out x of 1, which is equal to y1 minus x of 0, h of 1 divided by h of 0. So this will be equal to, what is y of 1? Y of 1 is 5 minus x of 0 we have just calculated, that is 1, multiplied with h of 1. H of 1 is again 2 divided by h of 0, which is equal to 1. So this is equal to 3. In a similar fashion, we have to calculate the values of x2, x3, x4, because we have already determined that the total number of samples in the input sequence will be 5. So upon calculating, we will find what is x of 2. X of 2 will be equal to y of 2 minus summation of k from 0 to 1 this will be x of k multiplied with h 2 minus k, whole thing has to be divided by h of 0. So this, when we expand, we can write it as y of 2 minus x of 0 h of 2 minus x of 1 h of 1 divided by h of 0. So what is y of 2? Y of 2 is value 10. X of 0 we have calculated it as 1 multiplied with h of 2. H of 2 is also 1 minus x of 1. X of 1 is equal to 3, something which we have just calculated, and h of 1, the value will be again 2. So the whole thing has to be divided by h of 0, that is 1, which is equal to 3. The next value that we have to find is for x of 3. So for x of 3, the formula will be y of 3 minus summation of k equal to 0 to 2. This x of k multiplied with h 3 minus k whole divided by h of 0. On expanding, we can write it as y of 3 minus x of 0 h of 3 minus x of 1 h of 2 minus x of 2 h of 1. You can see over here that one sequence of x keeps on increasing from 0 to 2. The other sequence of h keeps on decreasing from 3 to 1. Okay. So the whole thing has to be divided by h of 0. So y of 3 we will get from the output sequence. The value is 11. X of 0, that is equal to 1. H of 3. Because the impulse sequence consists of only 3 samples, 1, 2 and 1 at 0th, 1th and 2th instant, therefore the value of H3 will be equal to 0. Then x of 1 is 3. H of 2, this is available, this is equal to 1. Then x of 2, the value is 3. And h of 1, the value is 2. This whole thing has to be divided with h of 0, that is 1. So this will give us 11 minus 3 minus 6. So 9, and this will be 2. The last one we have to calculate is for x4. So for x4, the formula will be y of 4 minus summation k equal to 0 to 3 x of k h 4 minus k, whole thing has to be divided by h of 0. Putting the values, we will get y of 4. Y of 4 is 8 minus Next you have to find it for x into 0, h4 minus x1 h3 minus x2 h2 minus x3 h1. So the first one, because the impulse sequence consists of only 3 samples, so the first value will be equal to 0. The second one will be also equal to 0. Next one will be equal to 3 multiplied with 1, then 2 multiplied with 2, whole thing divided by 1. So we are getting this is equal to 1. So the final input sequence xn can be written as 1 for x0, 3 for x equal to 1, then again 3, then 2, and finally 1. Okay. So this is how we solve the problems on convolution and inverse system. That's all for today's class.